Good morning, students. Today we are going to see about geopolymer concrete. 1978. Actually, geopolymer is an inorganic aluminosilicate polymer which is synthesized from predominantly from the silicon and aluminum materials such as fly ash and GGBS. Here, the alkaline solutions are used to make the concrete. The use of this concrete helps to reduce the waste generations, and it will reduce the ground infills and reduces the carbon emission by reducing the usage of Portland cement demand. Unlike OPC, the geopolymer do not form calcium silicate hydrates for matrix formation and strength, but it polymerizes the materials into molecular chains and networks to create hardened binders. Silicate and alumina precursors to attain actual strength. It is also called as alkali activated cement or inorganic polymer cement. The main source materials are the aluminosilicate materials, which is rich in silicon and aluminum ions. It is made by using the byproduct materials such as fly ash, silica fume, slags, rice ash, red mud, metakaolin, etc. Here we are using the alkaline liquids which is act as an activators. It is a combination of sodium hydroxide or potassium hydroxide, any alkaline ions, and sodium silicate or potassium silicates. These are the materials which is used for making geopolymer concrete, fly ash, GGBS, fine aggregates, coarse aggregates, and activators. Here we are neglecting the usage of cement. Here, while mixing, we are using the alumina and silica sources, and we are first making the dry mix, and then we are mixing with the alkali sources, that is the caustic soda, that is sodium hydroxide and potassium hydroxide, and we are using the fine aggregate and coarse aggregate and water. This is the step-by-step procedure for the polymerization formation. These are the materials. This is the experimental investigation which is carried out to make geopolymer concrete in the laboratory. This is the pan mixture which is used to manufacture geopolymer concrete. First we are making the dry mix. Afterwards we are pouring the alkaline activators. This is the fresh concrete mix which is handled up to 120 minutes without any sign of setting and without any degradation in the strength. After mixing, we are checking the workability of the fresh concrete by means of slump count. Here, while mixing, we are using the alumina and silica sources, and we are first making the dry mix, and then we are mixing with the alkali sources, that is the caustic soda, that is sodium hydroxide and potassium hydroxide, and we are using the fine aggregate and coarse aggregate and water. And it has very much resistance to attack, and it has high strength, very low creep and shrinkage values. It has low heat of hydration when comparing to the normal concrete, and which is an eco-friendly material, and also it is geopolymer concrete will not freeze. The main disadvantage is it is difficult to produce because it needs skilled laborers to produce the concrete. It is a pre-mix only, and geopolymerization process is very sensitive. If any mistake is done, we are not able to achieve the required properties. It needs much awareness before making the concrete. The main applications are concrete pipes, which is used in the structural elements, pavements, retaining walls, precast elements, and the like water tanks, ramps. This is the first building which is done by using the geopolymer concrete. It is used. It is built in the University of Queensland Global Change Institute. Finally, we are concluding that geopolymer concrete is a concrete made without using Portland cement, and as such, it is environmentally friendly and energy efficient construction materials with an enormous potential in many infrastructural applications. The limited trial results shows that geopolymer concrete undergoes very little drying, shrinkage, and moderately low creep, and possesses excellent resistance to sulfate attack. Thank you.